All right, so this is session 7, and is this session 7? Yeah, this should be session 7, and our 4th week, if I'm not mistaken. So we are actually moving forward. We've covered a lot of ground. In our first week, we introduced I introduced you to data science. For some of us, it was our first time getting to know what data science is all about. Second week, we started looking at Python and introduced us to programming and Python programming. Then moving ahead to the third week, we looked at we moved further to look at explore further concepts in Python and yeah, some a whole lot of other stuff, right? I believe we are getting comfortable with the program and the course so far. And if you've been keeping up with the classes and what we've been doing so far, right? The things we're going to be discussing should not sound strange to you. All right, so I just want to encourage you to keep on with what we are doing. It definitely is not going to be easy. It was not promised to be easy at all. Anything that is worth doing is worth doing well, and anything that is worth doing is definitely not going to be easy, right? So you just have to keep going. You just have to keep showing up. You just have to keep doing that thing you're doing, even if you're not seeing any result at the moment. You're not like it's getting frustrating. Like it's getting frustrating, or it get frustrating at some point. Just continue. That is just all I would say. I believe some of us might need that because I can actually sense that it might not be going well for a whole lot of persons, right? So it's not a new thing. So that's just it about that. I just believe in saying some of these things once in a while, so as to like just motivate you and get you to continue firing on. So moving on, I will have to comment on what the class rep and the assistant has been doing so far. I currently don't have an assistant. In the previous cohort, I actually had an assistant that was helping me with some stuff like and relieving me of some of these things. But this cohort, I don't have an assistant. So having a class rep and an assistant as the ones we have currently is actually a whole lot. It makes the whole program a whole lot better because I can see how they are up and doing. Can see how they are very proactive and also taking initiatives, right? So I see everything that is happening. I see everything that is happening, and I'm not also ignoring the messages that are being sent or the messages that I'm being tagged on. Right, I'm seeing everything, and I'm doing my best at the back to ensure that like the whole thing is being sorted. Those ones that can be sorted, right? We usually have team meetings generally to discuss issues that pertains to this whole program. Right, we really want the student to have the best experience, right? So we are looking into like those issues that have been laid out in the group. So I think one of the most prominent issues is about the week 1 assignment, which some of us are still coming up to talk about, right? I think we sorted out that already, but I'm just going to, and the class rep reached out to me this afternoon actually. So I told him to do something. So after this class, I believe he's going to do that, and would get to do the best we can regarding that. So for the week 2 assignments, I believe there is no issue as regarding links, submitting links, and all of that we had in week 1. So the only thing in week 2 is just that we've not gotten our grades yet. So for those of us that are coming to me asking and telling me that they are yet to see the grades, it's a general stuff. I'm not done. I'm still grading the assignment. Like trust me, by this week 4, everything is going to be sorted out. So you will be getting your grades as quick as possible. It's just as so as to like help you gauge yourself and just give you an overall sense of um accomplishment. All right. So we are going to be doing that. So week 3 grades should, week 3, 4 grades by the end of this week should be ready together with week 3 grades. Week 2 grades will most likely be ready formed by Monday or so. So, but the thing is, don't focus on the grades itself. Just focus on doing what you are doing. All right. I think that is the most important thing. Try to understand and know what exactly it is you are doing here. And if you do, it will automatically reflect in your grade. So don't be so particular about the grade. Understand that it's necessary for you to see the grade, which definitely you would see and you are supposed to see. All right. So yeah, that's going to be it. So so now the class rep and assistant, they are automatically unmuted. So during the call, in case you want to say anything, you can just unmute yourself and say it. That's let's say during the class, if there is something that is happening that I'm not paying attention to, you can just call my attention to it. All right. So you are given that privilege, and it is also part of your responsibilities as well, just to help me as a tutor and help the class generally as well do better. So and also the meeting that was held, was it yesterday or Friday, as regarding uploading assignments or using Google Colab. I saw the meeting link, and I think this is the first time I'm seeing something like that in all the calls we've had. Like probably it might have happened, but I didn't see. But this is the first time I'm seeing it, and I'm really excited about it. Right, so I'm just keep it up, and I believe with this momentum, we are definitely going to get to where we want to get to. All right. So yeah, Gideon, Nigeria. Is there anything I'm missing that I need to address before we move on to the class proper? You are both on mute, so you can just unmute yourself. If there is none, just let me know that there's none, so we can proceed with the class. Hello.
Hello, good evening, sir.
Yeah. Good evening.
Okay, well done, sir. Thank you so much. The only thing that I would have said earlier was concerning the week 1 assignment, but yes, as you said, you've already reached out to Gideon and he's reaching out to me, so we'll work on that. I'll get back to the class. So that was like the pressing issue right now concerning the week 1 assignment. Thank you, sir.
All right. So thank you very much. So the material for today's class has been uploaded on the material and resource group. So you can download it and follow up with the class we're going to be having today. And please, class rep and assistant, remind me to send him a text. Is a like a textbook, but a soft copy, obviously. It's going to help you with the what we are going to be doing so far moving forward. So just remind me once the class ends. I'll send the material as well to the Telegram chats, right? So I think that is it about that. We are going to what did we do last week? Can we like just bring or let's juggle our memory a little bit. What did we do last week? What did we look at last week? Please, I need responses. Okay, let me share my screen. I'm waiting for responses. Okay, great. All right. So yeah, that's fine. I think we're all keeping up with the whole thing. So we looked at functions, we looked at control, flow statement, for loop and while loop. We looked at objects in Python. So if I should ask you any question now regarding this concept, I believe we should be able to answer it, right? At this point, we are past that level already, so it shouldn't be strange to us in any way, right? So if we should ask all um about any of this concept, whether functions, whether for loop, whether while loop, whether objects in Python, we should be able to comfortably answer them, right? So, but this is not the time to do that. We're going to probably have a time where we're going to just juggle our memory a little bit. But for today, we're going to be going straight to the next thing in our curriculum, which is NumPy. So today we're going to look at NumPy and introducing us to NumPy. All right, so let's get with it. Let's get started with it. So now I told us before that this course, this program, the data science course generally is segmented into three categories, right? So we have the first category segmented into three parts. We have the first part, which focuses on introduction to Python and just giving us a foundation, right? Helping us to understand the tool we're going to be working with, which is Python. So it should give us a solid ground to work with. So the second part of the program is going to be looking at some libraries, basically data analysis and data visualization libraries. So these libraries, these are like extensions of Python that enable you to do certain things in Python with the help of libraries, external libraries, all right? So we're going to be looking at one of them today, which is NumPy. So the subsequent classes will look at pandas, which is another one. Then we're going to look at matplotlib and Seaborn, right? So these are what we're going to be focusing on for this second part. So that should take us around 2 to 3 week-ish, right? So we should be able to wrap up with that within this time frame. And then after that, we will move on to machine learning. Right? I believe that is the part where most of us are anticipating, right? For those that might already have foundational knowledge on data science, we might just want to brush over this part and like move on to that particular one. So that's where we're going to like now start to unravel the core of data science and looking at the techniques, machine learning techniques that we can use in data science and all of that. So we're actually climbing up a mountain. It's just basically like climbing up a mountain. At the start or at the bottom of the mountain, it's you actually are not stressing yourself or straining yourself when it comes to breathing or the amount of effort you use in climbing, right? But when you get to a particular point of the mountain, like going ascending, it becomes difficult, right? So the difficulty level increases, right? So for you to get the peak of a mountain, you need to exert a lot of force and you just ensure that you are consistent with the climbing itself and you are doing what you're supposed to do to get to that peak, right? You might encounter things like shortage of breath, right? And a lot of other resistance. So, but if you really want to get to the peak, you need to overcome these obstacles or these challenges. And yeah, you definitely get to the peak. So why am I even saying this? I'm just using this as an not analogy or illustration to what we are going to be doing or what this program is going to be looking like. Is like climbing up a mountain. So we've actually moved past the bottom of the mountain, right? So we are climbing up. We are basically, uh, basically at the middle of the mountain. So the higher we go, the more difficult it is. All right. And realistically, let's say when we have like 100 persons that decides to get to the peak of a mountain, like realistically, it's not those 100 persons that will get to the peak. It's just few, some of them, right? So what determines the number of persons that or the people that will get to the peak is basically your determination, like, and your resolve to get to that peak. Once you've resolved in your mind that you're going to get to this peak, regardless of what happened, you definitely get to that peak, right? So once you resolve in your mind that yes, you want to go through with this data science program, regardless of the challenge, regardless of the obstacle or anything, you are definitely going to come out, right? So I just like doing things like this, saying things like this, just to kind of motivate us a little, right? Because I can understand um how frustration can set in at a certain point. Okay, so enough of that. Let's push in. So today we'll look at NumPy. For some of us, this might be the first time we are hearing this NumPy. For some other, it's not a new thing, but I'm just going to start um, from ground zero, and we're going to build up from there. So before I proceed, can everyone hear me clearly, and can everyone see my screen clearly? Please, I need feedback on that, so I know we are good to go. All right. So, and something else, some person submitted their link, a Google Drive link, but they didn't give me access to their file. So once I'm grading and I don't have access, I'll skip yours and go to the next person. So if you didn't give me access, just go now and give me access to your file, right? To make sure that you do this for subsequent assignments. But for those that didn't do it for week 3 assignments, please and with 2 assignments, make sure that you give me access. All right. So I believe every one of us here, at least, we are familiar with how to do that. I think if we are not, the class of an assistant will probably have put you through it already in yesterday's session. All right. So I just wanted to like chip that in. So today we are going to explore numerical computing with NumPy. So what exactly is NumPy? NumPy is okay. Before we move, let's just see what we're expected to get out of this lesson. So by the end of this class, or by the end of this material, basically, because we might not exhaust this material into this class. So by the end of this class, you should be able to understand, or you should understand the fundamentals of NumPy and its advantages over standard Python lists. All right. All right, so you should understand the fundamentals of NumPy and its advantage over Python standards. So I'm going to take us through this particular comparison on how NumPy has has an advantage over the regular list that we already used to. So also we should be able to create, manipulate, and perform basic operations on NumPy arrays. All right. So the third one here is that we should be able to apply NumPy for various numerical computing tasks. So NumPy is a very important library in Python, right? The reason why we are starting with NumPy is because every other libraries in data science, particularly, rely on NumPy for their operations. Like if you are writing or you are taking notes, just take this one, take this, or keep it at the back of your mind. Almost every libraries that we use for data science in Python, they rely on NumPy for their operation. So NumPy is like the backbone of data science, or let's just say numerical computing in Python. So anything that has to do with doing a lot of numerical computing and anything that involves mathematical operations and anything that just involves numbers in Python, NumPy is what is making it, or NumPy is what is at the background or is the backbone basically of that operation. Even if it is not explicitly saying it is using NumPy, at the back end, what is being used is NumPy. So I need you to get that. I need you to understand that because it's very, very important. And Pandas, which we're going to be looking at, Pandas is built on NumPy. So this is going to make sense when you are working or you are importing libraries. So for the sake of this program, we are not going to be looking at how to install libraries manually, because we've installed Anaconda already. The reason why we used Anaconda was to just simplify things for us and remove those layers of complexity that is involved in setting up our Python environment. So Anaconda just gives you everything set already. So you don't need to start installing this, installing that, setting this up, setting this, and all of that. So, but if you didn't install Anaconda, the way you're going to set up your Python environment is by installing Python interpreter separately. So after you've installed Python interpreter, you then start installing the particular library that you want to use. So there are some libraries that are built in Python, while there are some libraries that you have to install. So when you install Python, there are some libraries that automatically come with Python. So let me just see if I can be demonstrating this so you understand exactly what I'm saying. Okay, let's just chill. So just talk about. So I'm going to show you exactly what we mean by built-in libraries and external libraries. So you actually appreciate exactly what I'm saying. So for instance, now we have a library called, I hope I've explained what libraries are already. In our initial class, in the initial classes we had, I think I explained what libraries are and packages, all right? So let me just refresh our memory. Libraries or packages, we call them libraries. Let's just stick with libraries. They are basically a collection of functions of functionalities of functions basically that is specific to a particular task. All right. So if you write a lot of functions and it is being attributed to a particular task, you can easily package those set of functions into a library and then deploy it to Python, and then anybody can download it and use it. So that is what the library is, right? So NumPy is one of those libraries, right, that you can use. So it was written by, I think, I don't know exactly, but it was written by someone, all right, that's someone that is an external person from Python, and then the package was deployed to Python Python package community, where you can have access to it and then use it for whatever you want to use it for, right? So now I told us that we have two kinds of libraries. We have the built-in libraries. I've forgotten how to spell libraries. Oh my god. Okay, libraries, right? I think this should be correct. And we have external libraries, right? Okay, so now built-in libraries are libraries, as I've said, that comes in with Python. You don't need to install them. Okay, so for the sake of this program, we're using Anaconda, as I've said. So we don't install any data science library. It comes installed with Anaconda. So, for example, now there's a library called Math. Math. We have we have a library called Math. We have a library called OS. We have a library called Sys. So don't concern yourself about what this library do, right? So I just want to use it as use them as example. So these libraries here, they are built-in libraries. You don't need to install them, all right? So you can, as long as you have Python interpreter in your system, you can easily just import this library. So I'm going to introduce you to another concept in Python, which is called import. So if you want to use a library in Python, you have to import it. All right, you have to actually import it, and you import a library using the import statement. So the import statement is used to all right, let me just use the same word, import libraries into our working environment. All right. So once you import that library, you can now have access to all the functions of the library. All right. So for instance, now I want to use math library. I have to import it, right? Importing it. Let me just convert this to Markdown. Build libraries. Okay, so this is the import statement. I want to use math library. I will come here and say import math. So what I've done is that I've brought all the functionalities of math into my working environment so I can use them and do what I want to do. So for instance, now to check all the attributes of math, what do you use? In this case, I want to know what I can do with math. What do I do? Like what function do I use? I think we've looked at this in the previous class. I just want you all to remind me. All right, thank you, Edidion Moses. Yeah, you're correct. So we use the dir function. The dir function, it takes an object, right, and give you all the attributes, all the functionalities, all the methods of that particular object. So in this case, the object we want to like review is the math object, right? So I'll come here and put math there, and then I'm going to get this. Let me just put print so I get it like in a more better way. All right, so these are the different let's say methods of math. So these are the things I can do with this particular library. All right, so if I come here and I say math dot let's say prod, right? I don't know what prod does, so I'll say math.prod is a function. Now I want to introduce us to something, another thing. I don't know if I've done that already, but when you don't know what a particular method or function does, there's a shortcut or there's something you can do to quickly see how it is being used or what that particular method is being used for. So once you see this particular method and you want to know how it is used, how many arguments you are going to use, and the kind of data type that it works on, you are basically going to put question mark after it. All right. So if you put question mark after it and you run it, enter, Python is just going to give you an explanation of an explanation of what that particular thing does. So if you put question mark, either one, I think two question mark, two should work if I'm correct, right? So this is basically the explanation here. You can see we have the doc string. So this is different from this particular function here, doc. All right, this is different from this doc function. This is not a function, right? This is an attribute. All right, so this is an attribute, so you don't have the opening and closing here. So that question mark is different from this doc attribute. This doc attribute just extracts the documentation or the docstring of that function, and this is the docstring. But the question mark gives you a kind of a more descriptive explanation, right? A better overview of that particular function. Let's just put it that way. So you see that in this in the output, we even have docstring as part of it, and we have the signature here, right? So what this first one does is it tells you the argument that the function takes. So you can see here we have the first argument here of the parameter, which is an iterable. So an iterable is what? An iterable is, what's an iterable? Like, just quickly, I want to just be doing this so I can juggle your memory, and I'm sure that you have not forgotten what we've done so far. So what's an iterable? Someone, Felix said looping through. I can see someone is saying a list. Someone is saying a loop, and a table can be a list. Right. So I think you all have an idea, but an iterable is a sequence or something you can loop over. All right. An iterable is like a noun. Let's just put it that way. Something, an object, a data type in Python that can be iterated or can be looped over. So a list can be an iterable. A tuple can be an iterable. A string can be an iterable, right? So that is basically what an iterable. So this particular product takes an iterable, all right, and then this asterisk basically mean it can take I don't know. I think we have this division here. Let's see. Let's just see, and let's just go through and see exactly what it does. So what this particular does is calculate the product of all elements in the input iterable. The default start value for the product is 1. When the iterable is empty, it returns the start value. This function is intended specifically for use with numerical values and will reject non-numerical type. So you can see that that is what this particular product function does. You can explore that on your own, so we don't have the time to start going all of that. I just want to give you an idea of how we use function, how we import libraries in Python. So you see we imported the math library, and we can now have access to it in our working environment. Let's say I want to use the OS library. So I'll come here and say import OS, all right? So this OS is basically operating system. So it gives you access to functionalities that you can use to interact with your operating system. So when you're working with Python a lot, you're building applications and all of that, you would use this particular library a lot. So let's see what this particular library have for us. So they come here and see dir os. Let me print. So you can see that it has a lot of stuff here. Now, there's some package or some library that are very big, that they have modules inside of their inside of that package. So you have, when you import that library, you have to import a particular module from that library that you want to use. So I'm going to explain that and show us that later, right? But I just want you to know that there are libraries. There are some libraries that are small, while there are some libraries that are actually big, right? They have a lot of things you can do with it. So these are usually called packages, right? So they are more extensive in their functionality. So this is OS, right? You can use OS for a lot of things. You can explore that on your own and check them out. So this is it for built-in libraries. So now for external libraries, right? For external libraries, we are going to have something like NumPy, as we are seeing now. We have pandas, we have matplotlib. So these ones are particular to data science. So, but we have a lot of external libraries. We have Seaborn. We have scikit-learn. science for machine learning. We have TensorFlow, we have PyTorch, we have I think we have SciPy, we have Stats Model. So we have a lot of libraries, like it's just a lot, right? We have a lot of we have OpenCV. So you can the libraries in Python are too much, right? So the possibilities with Python is limitless, is endless, right? Because of the external libraries that we have. A lot of persons, even companies write libraries in Python that you can use for something. I think scikit-learn, I'm not so sure, but I think scikit-learn was written by Google, either Google or Meta. I'm not so sure. So, but TensorFlow is written by Google. PyTorch is Meta, right? So SciPy, so even individuals, you yourself, you can write a package in Python and like deploy it to Python, and then every other person can have access to it. So that is what external libraries are in Python, right? So today we are going to be looking at one of those external libraries, which is what NumPy. So normally, in a normal setting, you actually have to install this external library. So how you do it is, let's say you've not installed it or you're not using Anaconda. What you do, normally you install it in your command prompt. I don't want to complicate stuff, but since you're working in your Jupyter notebook, the way you write command prompt in your Jupyter notebook is by starting with an exclamation mark, and then this is the command you use to install any library that you want to install. So if, let's say I want to install NumPy now, I'll just say pip install NumPy. So this is the command for installing external libraries in Python. But since we are using Anaconda, NumPy is already installed, so it would tell us that, oh, NumPy or requirement already satisfied. So let me just try installing NumPy here. So I'll run this command now, and what it is going to do is that it's going to reach out to PyPy. So I think Python package index or something like that. So it's like a repo where all the packages in Python are indexed. So if you create a package, you can just send them to that particular repo. So once you say pip install something, pip points at that particular list of packages to see if it is available, and it now fetches it from the internet and downloads it to your local machine. So that's basically what pip install does. So it is searching for NumPy to see, but before you do that, it looks at your local libraries to know if you've downloaded or installed it yet. If not, it's now going to go to the internet and search for it and then download it. So I don't know why it is taking time to do this, but let's just move on. I just wanted to show you how this thing works. So let's move on. So we're going to be looking at NumPy. Let's work with the assumption that we already have NumPy installed, which actually we do. So with Jupyter Notebook, we already have NumPy installed. So we're just going to see how we can use NumPy, right? So let me create a new notebook because that one is still running, and it's still running, but let's. So I hope you all are still following and you can see me clearly and see my screen clearly as well. Please let me get feedback. Just wondering why this isn't. Anyways, so let's just move on. Now to import NumPy, we use the import statement. Let's come here, importing NumPy library. I'm going to say import NumPy. What exactly is happening? I feel something is happening somewhere. That the server, my Jupyter Notebook server is all right. So it has okay, yeah. The interpreter is up. Okay, so you can see now from this particular one that has finished running. Let me see that this is pip here. Pip, you can use pip to do a lot of stuff. Install, download, unlock, freeze, inspect, list, right? So if you are working with Python and you're using it to like build stuff, you're going to use pip a lot. So just so you know that, so like you don't come out of this program and you have no idea what pip does. It's actually not going to make sense. So you can see what I'm saying here is that when I try to install NumPy, see what I got here. Requirements already satisfied. What this statement means is that NumPy has been installed already, right? So it is installed in this, you can see Anaconda 3, blah, 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 and this. So it means that NumPy has been installed. So let's try to install something that might not have been installed. Let's say install OpenCV. So I'm going to cancel it, but I just want to show you how pip installs packages. So I'm going to run this. I think you should look for OpenCV in our local system, our local folders. And if it doesn't see it, it then goes to the internet and tries downloading it. All right. So as that one is working, let's go straight to NumPy. So now we are trying to import NumPy. Once I run this, you see that NumPy has been imported. So someone is asking to import NumPy into Jupyter Notebook. Do we need internet connection? No, you don't need internet connection to import. What you need internet connection for is installing NumPy. So if you want to install any package, you actually need an internet connection. But if you're importing, as long as the package has been installed already, you don't need an internet connection. It would like work fine, right? So yeah, that is about that. All right. So now that I've imported NumPy, let's explore it, right? So what exactly is NumPy? Let's see the content of NumPy. I'm going to print this instead. Print. So you see that NumPy has a lot, like a whole lot, because it's not a small library. It's a very big library, or let's just call it package. So it has a whole lot of stuff that you can use, right? And trust me, you're not going to use up to 20% of these things, but some of them can come handy. So all these methods you're seeing here, they are just for numerical computation, for performing numerical computation, all right? So these are the things we are going to be like looking at and working with, all right? So that is it about libraries, and that is it about installing library. So you can see for this particular one too, it's already installed. I think Open Anaconda comes with it. So now, when you are installing Anaconda, you'll notice that it takes a lot of time, and the file size of Anaconda is actually large. This is a big reason for that, right? Because Anaconda comes with pre-installed packages. So most of these packages that we have, I think even all of them, as long as they are for data science, they come installed with Anaconda. So this TensorFlow now, I think the file size or the package size is almost about 1 gig, right? This PyTorch, not necessarily 1 gig, but like I think around 700 to 900 MB. PyTorch as well is also a large package. So these things they are large in file size. So that is why Anaconda installation package is that large and takes time to install. So that time it takes is it's actually trying to just set up everything for you, so you don't have to be installing them one after the other. So let's go back to our course material. Now we've introduced us. I've introduced you to NumPy. I've told you what NumPy does. So NumPy is an abbreviation that stands for numerical Python. You can see that we have num and we have py. Num numerical, py Python. So that, as I said, anything that have to do with numbers, numerical computation, they go to libraries what NumPy, right? So that is it. So next we're going to look at NumPy arrays. So we're going to look at NumPy arrays, and then we're going to move to basic operations in NumPy. Then we're going to look at array manipulation, and then we're going to look at aggregation functions and statistical operations, and then we're going to look at some other things and concepts in NumPy. All right, I think that's fair, right? So let's just move on. Now, what is NumPy? As I've said, NumPy is a short form for numerical Python. All right, it's a fundamental library in Python used for numerical computing, and it provides support for large multidimensional arrays and matrices. Like I'm going to break down or explain what arrays are and also what matrices are, right? So these two things are the fundamental data type in NumPy. So another thing you need to know is that every library usually comes with its own specific or unique data type. All right. Every library usually comes with its own specific and unique data type. For example, NumPy comes with its own data type, which is an array and matrix as well. These are not data types that are in the original or regular Python, right? This data type comes with NumPy. For pandas come with a data frame data type. All right, so and these are the things that you need to learn. These data types, once you understand how to work with these data types, you understand how to use that particular library. So everything around that library or package, it revolves around the data type that it is working with. So it provides support for these data types, right? Arrays and matrices, along with a collection of mathematical functions to operate on these arrays efficiently. Now, see what I said before. NumPy at its core, and NumPy is at the core of almost every scientific and computational Python ecosystem. I think I can't emphasize this enough. Like every time you see any scientific stuff in Python, I think even I think they use Python, right, for some calculations. So when they're using Python, although they might use some other programming languages like C++ for precision, but when they use Python for any computation, what is making this computation happen is NumPy. Just know that, right? Right, whatever thing you're doing that involves number, even your machine learning as well use NumPy at its core. Even AI at even the AI that we all know at the core, it uses matrix like arrays and matrices. And these matrices, they are basically like at the core of NumPy. So NumPy is like the backbone of every scientific computation or anything that has to do with numerical computation in Python, right? So yeah, let's just leave it at that. When we get to that point, we're going to explain that. So it serves as a foundation for libraries such as pandas, which I've said, SciPy. SciPy is short form for scientific Python, right? Matplotlib is like a library for data visualization. So anything that has to do with visualizing data, Matplotlib is it, right? So the same way you can visualize data in Excel, in Power BI, in Tableau, you can use Matplotlib, right? It is very powerful. And the flexibility that comes with it is very good. So I'm going to look at Matplotlib. We're going to look at Seaborn. Seaborn is built on top of Matplotlib, so it makes visualization easier. You write less code for Seaborn than you write for Matplotlib. when we get there, you're going to see. So trust me, like we have an interesting road ahead. And we have a lot of interesting things to look at and to explore going forward. So just ensure that you stick with the class and you follow through with what we are doing. So now at the heart of NumPy, we have what we call ND array. All right. And I think that's what I'm going to spend my time in this particular class today explaining. I'm going to spend my time explaining n-dimensional arrays, one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Tomorrow we're going to now conclude with NumPy. I want us to finish with NumPy this week and then move to pandas in the next class. So we're going to focus our attention on ND array. So that is basically what is at the heart of NumPy. So what it means is an n-dimensional array, and from our mathematics and mathematics, you know that whenever we see n something, basically n can be any number, right? It can take on any number. So the ND array is a fast and flexible container for large data set in Python. These arrays facilitate operations on large numbers of data points efficiently, making NumPy essential for tasks like mathematical operations, statistical analysis, simulations, and more. I'm not going to like go through this. These are just like grammar. So you can go through them by yourself. You don't have that time. So at least you understand the core of, or the idea I'm trying to pass through. Now let's look at the array itself. Let's look at what NumPy array is. So you start been talking about array. Oh yeah, what does it mean? Okay, that's a good question if you're asking that. So NumPy array is like a data type. Like, you know, we've talked about data types in Python, we talked about list, we talked about tuple, we talked about dictionary and set. So now we are going to introduce us to a new kind of data type in NumPy. It is called an array. All right. So now let me just demonstrate it so it doesn't sound abstract. So what do I do? Let me delete this. Delete. All right. Okay, this. Okay, so now how do we use NumPy? Or how do we create NumPy array? Remember, if you want to create a Python list, let's say Python list. How do? You just open and close a bracket and say 1, 2, 3, 4, 5. This is a Python list. If I come here and say type, what is the type of this object I just created? It will give me this. I don't know why this interpreter is taking time to do. So it will give me, this is the data type of this object, right? It's a list, regular list. Now let's create a NumPy array. So creating a NumPy array. So how do I create it? I use a method in NumPy to do that. So before I go to creating it, there's one thing I want to introduce us to, which is called an alias. So right, this is what I mean by alias. ALIAS. So it's like maybe another name for something or something you use in place of something, right? So when you're importing stuff in Python, you most likely import it using an alias because you're going to be repeatedly calling that thing, like using it like and calling functions or methods. So you don't want to always be typing NumPy dot NumPy dot NumPy dot this, NumPy dot that, NumPy dot array, NumPy dot this, and all of that. So you want to give it a very short alias so you can use that short form repeatedly, making your code look very clean and easy to read, right? And even less stressful on you as well. So how do you associate an alias with it? So I'm going to be opening the attendance now, so you can all sign and start signing. So the attendance is open. So all right, let's give me some hits. Just give me some second. I think I was logged out, so I just have to log again. All right, so you can now sign attendance. Okay, so to get your alias, you use this particular keyword which has AS, and then your alias would follow. So your alias can be anything. It can be NP, it can be NPY, right? But conventionally, we use NP for NumPy. When we are importing NumPy, this is how we import it. Import NumPy as NP. So whenever you whatever you have for NumPy, it is transferred to this particular alias, right, which is like the representation of this NumPy. So you don't be typing NumPy every time. You can just type NP and get the same thing as when you type NumPy. So if I come here and instead of NumPy, I just type NP, it's going to give me the same thing, all right? And it's going to give me the same thing. So now when you try using the NP is not defined, so I'm going to run this cell so that it's going to register it. I'm going to run this, so we're going to get this. So this is exactly the same thing. So you can now start using NP as NumPy. So this is now the alias, and we can use it throughout our code. All right. I hope that's very clear. So to create an array, we will basically use the .array function or method. So if you go scroll in this dir output, you should see there's a particular function called array. Right, so you can see it here, array. All right, I hope we can all see that. Let me zoom in a little bit. I'm highlighting it now, array. So this particular method, let's see what it does. So let's come here and say array and then put question mark. So you can see a very neat documentation of what this method does. So this is a good way to explore things in Python. Things that you don't know how to use, just put question mark at the back. And Python is going to give you like a very, very nice documentation on everything. So this is the doc string. It will most likely return the doc string to you. So this array, it takes in what? It takes in an object, all right? And it takes in this particular parameter, this parameter. So there was something I didn't explain to us when I was talking about function definition. There is this kind of parameter that we have here. It is called keyword parameter or keyword argument, right? What we mean by keyword is that when you like defining it, you define it as key and word. So this is the key followed by an equals to and then the word. So it's a way of assigning a value to in a function even before you call the function. So even if you don't define it explicitly, that particular argument is going to be retained by default and you can use it. So all these things that we have here, they are keyword parameter, and we are going to be working with them throughout the course of this program. So don't worry, even if you don't understand what I'm saying now, don't even bother yourself at all. Trust me, you will definitely understand all these things because that is what we are going to be doing. Right? We're going to be literally using all these concepts. So by the time we have done it several times, you'll get to understand it. So these are the arguments that the array method takes, right? So it takes an object. So the object most likely will be a Python list, right? So it will be a Python list and then it's converted. So you can see here the array object, it explains everything that it does. An array, any object exposing the array interface, an object whose blah, 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 returns an array, all these things are just grammar. What I'm just trying to tell you that if you have to pass in a value and that value will be converted, you can pass in a value or pass in a list and it will be converted to an array, right? So the data type, you can set the data type and a lot of other things. So let's not just focus on all these other ones here. But let's see the examples. So if you scroll down, you see that we have some examples here actually. This is going to help you learn. So you can, the question mark is a very powerful thing in Python. It helps you like understand some particular methods. So once you scroll down, you see example on how they can use, or you can use this method. So you can see np.array. So the array takes in a list. This is a list here, and then what it returns? It returns an array, right? So this is not longer a list, it's now an array. So you're literally converting this list to an array. So you can see the same thing here. It takes in a list of integer and float, and then it returns this, right? You can create more than one dimension. I will explain what I mean. You can create one dimension, 2 dimensions. You can create 3 dimension as well. So you can even make it more complex and all of that. So we're going to explore how we can work with arrays. So like you need to like get comfortable with arrays or working with arrays. So let's move on. Let's continue flying. Now let's try to create an array. Creating an array. Let me see if there's something that I need to talk about. So before I continue, I need to give us differences or reasons why we are using NumPy for numerical computation and why we are not using lists. So for several reasons, NumPy is preferred for numerical computation. One, because of its performance. Like NumPy is very fast. Like when we say fast, we are referring to NumPy. NumPy operation is very, very, very fast. So if you're performing an operation on NumPy arrays, like a lot of numbers, like plenty of them, and you are performing the same operation on Python list, the NumPy array would be almost like, I don't know the particular number, but it would be a whole lot faster than the Python list. And this is because of how NumPy arrays are created and stored. And another reason was because NumPy is implemented in C. C is a programming language. All right, so the compiled language, which is very fast. So that's one reason. But another important reason or main reason is because of how NumPy arrays are stored. Now, one thing you need to know about NumPy is that NumPy don't allow you to store multiple data types in its array. All right, it kind of restricts the data type to a particular data type, so as to perform an operation or to store it in a contiguous manner in memory. You know, when I talked about lists and how to store the memory, like it's like a pointer pointing to different elements in that list at different locations in the memory. So if you create a Python list, let's say you create a list of 1, 2, 3, 4, it will not be stored consecutively in memory, like 1 after 1, 2 after 2, 3. It will be stored separately, but the only thing that connects them is the index and then a pointer. So the pointer points at the index, points at the different elements at the different positions in memory. So when you're running an operation, it is very inefficient because of how it is stored in memory. But NumPy is stored in a contiguous manner. Contiguous manner basically meaning that it is stored like together, right? They are together. So when an operation is performed, it is performed like on that particular array simultaneously. We usually call it vectorized operation, right? So we're going to get there and we're going to look at how vectorized operation works. So NumPy is fast. That is the idea or the main point of all this explanation. And the speed is what makes it preferred to Python list when it comes to performing numerical operation, right? So it also uses less memory in PyM than list, right? As I said, it stores data more compactly, right, than lists that are stored scattered, like scattered all over the place and all of that. So those are the basic 2 basic reasons why we prefer NumPy to Python. So almost every library uses NumPy when dealing with numerical computation. So now let's move on over here to creating an array. So to create an array, use np.array, and then we're going to have in lists. Like let's just start with just a number. Let's see what will happen. Now this is what we call a scalar. Let me print out the type. Let me pass it to this variable. Array 1. I'll compare array 1 rather. So you see that the data type of this particular array now, or this particular object is what a NumPy dot nd array. So you now see that when we use the type function and we are seeing a different kind of data type. It's no longer list, it's no longer list, it's no longer tuple, it's no longer dictionary, it's no longer all of those things that we've looked at, right? It's now a different thing, NumPy array. So now let's look at the things that can be performed on a NumPy array. So how do we do that? We use our dir and then we pass in array1 to it. Then we run that. So you should know this print function. So these are the different things that can be performed on an array. So you can do all these things on a NumPy array. Now, don't get confused. Remember we did this particular dir on NumPy. So this one is for NumPy itself, but this one is for when you create an array object using NumPy. So if you've understood what objects are, which we explained in last class, you should understand what is going on here. All right. So these are the objects that are attributed to the NumPy array data type, right? The NumPy array data type. So this is how we can. This is like the most basic array that we can create, just passing in a single value here. So, but we can make it actually more complex by passing in a Python list. So let's come here, say 1, 2, 3, and then run it. Let's remove this. So this is NumPy nd array. Let's print the array. I'll come and say array1. So you can see it's just giving you this same thing, right? Let me print the list itself. 1, 2, 3. You can see the difference now. This first one is what? This first one is a NumPy array. Just come and put it. And this second one is what? The second one is a Python list. All right. So we have NumPy array here. Okay, so I have to terminate the string here. So you see the first one is a NumPy array, while the second one is what? A Python list. So you can see that the output is not even the same thing. So this is a way to know which is NumPy and which is not. The list, you can see the comma there. Why the NumPy array, there's no comma. Like, this doesn't really mean anything, but it's just a way of like presenting a NumPy array and a Python list. So this is how we can create an array. Now let's go further to see how we can create different dimensions of arrays. All right, different dimensions of arrays. So we have different array dimensions. We have array dimensions. We have 1D array, which basically means one-dimensional array. We have 2D array, which is two-dimensional array, and we have 3D array, which is a three-dimensional array. So these are different types of arrays we have in Python, and in NumPy we can actually create them. So we are going to be working with these kinds of arrays: one-dimensional, two-dimensional, three-dimensional. So an array is an array, but it can now be created in different forms, having one dimension, two dimension, and three dimension. But before we go into seeing how we can create these different types of dimensional array, let's look at the attributes of arrays, right? So I'm not even done with how we can create arrays. So you can see on the material here that we can use this np.array function to create an array, and what it does is it converts Python list or tuples into NumPy arrays. So that is what it does under the hood. So we also have some other built-in functions that we can use to create an array. So let's quickly look at them. So we'll look at np0s, np1s, np arrange, np linspace. So let's quickly look at them. This is actually becoming more interesting. So we have the first one, which is np.zeros. All right, so if you scroll back to this particular attribute of NumPy, if you go to the last part, you see that we have an attribute called zeros, right? np0. So to access that particular method, we are going to have to access that particular method, we're going to use the dot notation to access it. Someone is saying 1D is equals to scalar. Not necessarily. Scalar is, I think, is a single value, right? 1D is a vector. It's actually a vector. One dimension is a vector. So once you're having a list, like it now becomes a vector. But if it's just a single number, that's a scalar. All right. So for example, now when we are creating this particular, where is that? When we created just 3 without using a list, that's a scalar. But once we now start having this one dimension is a vector, two dimension and 3-dimensional arrays, they are now referred to as matrices. All right. So you can now start like correlating them with what you've done before in mathematics when you look at matrices and rows and columns and all of that. So we're going to look at them. So let's look at how we can work with zeros. So just assume that you don't know what zeros, np.zeros does, like you're trying to like use it. So what do you do? So what do we do? Like I want you all to like tell me what to do. Assuming I don't know how to use np.zeros, what's the first thing I'm going to do? Exactly. So I'm going to use a question mark to get the description of that particular method. So I'll just come and say np.zeros with question mark and then run it. I'm going to get all the explanation I will need to use that particular function. So you can see here, the zeros, it takes in a shape argument. All right. So this shape argument is explained here. The shape argument can be an integer or tuple of int. So this is when you now start interpreting these things in light of what you already know in Python. What does integer or tuple of int mean? So an integer can be just one integer or a tuple that contains 2 integers. So the shape of the new array, e.g. 2 and 3, this is a tuple of integers and this is an integer. All right, so you can also have data type. So the data type can be whatever. So we're going to leave that. So if you just scroll down, you will see examples of the use of np.zeros here. You can see that for this particular one, you can see it is just having a single value, which is an int. We have this one, the data type is specified to be an integer, right? So we have this one to be a tuple of int as the input, and we have this and we have that. And so this is a very neat way to understand the function that you want to use, right? So let's just move on. So now that we understand what zeros do, we're now going to try to create an array of zeros. So what is np.zero does is it create an array that has only 0 as the value. So what you would define for this particular or what you are going to put as an argument is the shape. So what kind of shape do I want this array to be? So if I come here and I put just 1 or I put 3, this 3 corresponds to, in NumPy array, I think I'm going to do this when I go to 2-dimensional array, but NumPy arrays has what we call rows and columns. For one-dimensional arrays have just rows. There are no columns, all right? So two-dimensional arrays have both rows and columns. While three-dimensional arrays have like a third step, it has rows and columns, and it has another different axis, right, which is the third dimension. We're going to look at that. So, but for the first one, which is going to be 3, this 3 represents, I want just 3 rows in my array. If I run this, I'm going to get a NumPy array with 3 zeros. So I have this 1, 2, 3. All right. If I change it to 6, you give me 1, 2, 3, 4, 5, 6. If I change this to 10, you give me 10 different values, right? But if I come here and I change this to a tuple of int, and I say I want 4 rows and 2 columns, this basically means 4 by 2 array. So whenever you are working with NumPy, the first value is usually corresponds to the number of rows you want, while the second value always corresponds to the number of columns that you want. So if I run this, I'm going to get this. So in this case, I'm going to get 1 row, 2 row, 3 row, and the 4th row. And now I'm going to be getting 2 columns, 1 column, this first one, and the second column. So this is how we work with arrays, right? So you need to start understanding axis in NumPy. So if you've done this like mathematics stuff back in the days, I think you would understand and appreciate it better. So this is basically matrix, like matrix that we're all familiar with, all right? Rows and columns. Rows are the horizontal aspect of the data, while columns are the vertical aspect. So rows are the horizontal from left to right, while column are the vertical from top to bottom, right? So this might be confusing. It might actually be confusing at first, but just try to map that in your head so you don't get confused and don't mix everything up. All right. So this 0.0 that you're having here is just like, it basically is telling you that this number is a float, or the data that we have here is a float. So we can change the data type. If I come here and say d type, all right, equal to float, this float, and I think it should be float 32 or float 64. Let's see. Let's just choose float first, but I think we have 2 options, usually float 32 or float 64. Okay, let's try floats. Okay, let's see. So, but let's work with this first. So we have float as data type. So to give us float, but if we change this to an integer, int, it's going to give us an int. So we are going to have just an integer. There is no decimal point again, because the data type of the values in the arrays are now integers. So by default, the data type is a float. Now, just link this to what I'm going to explain to you now. By default, let's go back to checking out np.zeros using question mark. So by default, you can see we have this parameter here. So whenever we have this keyword or default argument, we can call it default argument. So when you are defining your function, you can actually include a default argument that when you create or when you run that function, there is a particular value that will be there by default. It will not change unless you want to change it, right? So by default, the data type is a float. So if you don't indicate or like type out or determine the data type while you are creating your array, by default it will be a float. But if you want it to be an integer, you can just change it to be an integer. All right. So this is how we can use this keywords argument. So we have default keyword arguments or default values in functions while creating functions. So this is how we can create np.zeros. All right. So that is for creating zeros. So sometimes you might need this, but most of the time you might not need it, right? So let's move on. So we have np.ones. So let's do the same thing. So what this will do is just create ones for us. So I'm going to do 2 by 4. So this is going to have 2 rows and 4 columns. You can see it has 2 rows and 4 columns. So this is a 2-dimensional array, right? So it has rows and axes. So that is 2-dimensional. The first dimension is the row, second dimension is the column. So that is why we call it 2-dimensional array. But if you want to create just 1-dimensional array, you can just put one value there and it will be 4. So this is 1-dimensional array. All right. So that is how we can create and ones using np.ones function. So we also have another argument called np.arange. So this is similar to the range function that we looked at. Let's use question mark to check it. So this return evenly spaced values within a given interval. So these are the parameters: start, stop, step, data type, and all of those other things, right, that you might not even use. So, but for this, we're going to be looking at it. It's similar to range function. So if you have range, if you know range function, you know this one. So if I want to create a NumPy array, let's say I put in 3 start, and then I say 10. I'm going to create a NumPy array between 3 and 10, right? So we're going to have this particular array. So if I say I want the NumPy array between 3 and 18, it will give me this. If I say I want the data type to be what? Float, it will convert it to float. You can say now as dot, right? So that is basically, you can do that. But I think there is something else. You can determine the shape. Let's see. All right. Okay, so there's no argument, or there's no parameter for shape, right? So np dot arange. All right. Okay, arange. This is it here. Okay, so I'm sorry, this should be this. So it works the same way with your range function, but it returns a NumPy array instead of a list, right? So if you want to create a range of NumPy array, and this is usually 1-dimensional, so you can create this using np.arange. All right. So if you add a third element here, it's going to be the step, right? The same way it is done, or the same way it happens in range. So if I run this, it's going to give us between this one and this one, you're going to have 3 values: 3, 4, 5, 6, 6, 7, 8, 9, 9, 10, 11, 12. If I change this to 2, it does the same thing. All right, that is for that. So we have another one called np.linspace. Question mark. What does it do? We have start, stop, num50, endpoint, all of this. So let me just explain it because of time, and we're not going to go through the documentation. So what linspace does is that it creates evenly spaced values between a predefined range. Let's say we want to create 50 values between 1 and 2. np.linspace can actually do it for you. So you might be wondering, how do we create 50 values between 1 and 2? Between 1 and 2, there is nothing now, right? Like that's what might come to you. Like that's what you might be thinking about immediately. Between 1 and 2, there's no value. Actually, in mathematics, there is actually an infinite number of values between 1 and 2. So when you use np.linspace to create that, it basically just divide the whole thing and do some mathematical stuff and give you a set of number that are evenly spaced, but between 1 and 2. So let's just come here and say 1 and 2. You will see that we have, I think the default is 50, right? Based on what we see, the default is 50. So if I come here and change it to 20, it is going to give me just 20 values, all right? So, but the default is 50. So this is the start and this is the end. So the first number in this array will be 1 and the last number will be 2. So if I come here, yeah, that is basically going to be, you see that every other number that is between 1 and 2 they have decimal point and all of that. So if you calculate the distance between this one and this one, it's the same distance between this one and this one, and it's the same distance between this one and this one, right? So that is what linspace does. It gives you a precise spacing between a number and the following number within a confine or within a predetermined range. So let's say I want to create 20 values between 1 and 5, right? It's going to do it for me, right? So between 1 and 5, it's going to like create evenly spaced number. Right? You have 1.2, we have 1.4, 1.6, 1.8, we have 4.3, and all of that. So this is what line space do. If I change this to 20 and I change this to 100, and I want to create 1,000 numbers between 20 and 100, I'm going to have this, right? So it's going to do that for me automatically. So you might need it to do some certain things. So this is what linspace does in NumPy. So let's just move past. Time is already like we have less than 30 minutes to do. So that is what the built-in functions. So we are still on creating arrays. So these are the functions we can use to create arrays. We can use our normal np.array, which would create an array from a list that we actually define ourselves. Why np.0 create zeros? Well, you have to define the shape. np.ones create ones. np.arange creates a range. np.linspace creates evenly spaced numbers between a predetermined range. Right. So this is how we can create different arrays in NumPy. All right. So I hope everyone is still following. Hope everyone is still following. So I continue. All right. So now we're going to look at attribute of arrays. So let me I think I have to look at the different dimensions before looking at attributes. So let me change this to 2, or let's say 3, 10. All right, so let's look at different arrays, creating different dimensions of arrays. So let's look at creating one-dimensional arrays. So we've already looked at how we can create 1D. So if I come here and say 1D, or let me just say array 1D. I'll come here and say np.array, and then I have my list. So let's say I want to create 1, 2, 3, 4. Then this is array 1D. If I print it out, array 1D, you see I have my array. This is a one-dimensional array. So there are different attributes that these arrays have. So these are the main one here. We have shape, we have data type, we have size, we have dimension. So this that we've created here is an object. And remember what I said, that objects have attributes. So these attributes I just mentioned, they're specific to arrays. So if I come here and I say array 1D dot shape and I run it, I'm going to get the shape. So the shape here is 4, nothing. So what does 4, comma mean is that we have 4 rows and no column. So this is a one-dimensional array. So whenever you have a one-dimensional array, I want to check the shape. This is the output you would always be seeing, right? So if I come in and I check the size, so the size is usually the total number of values in your array. So for this array, the size is going to be 4, right? If I increase it to like let's say 5, like I put other numbers in it, the size is going to be 11. Now, what the size does, it counts. It counts the number of values in my array and then output. That's the size of an array. Why the shape is what the dimension. So, or the shape is the number of rows and columns. So the shape now is going to change to 11, right? So we have 11 rows and no columns. So the other attribute we have is ndim. So ndim basically tells you the dimension of that particular array, whether the array is one-dimensional or two-dimensional or three-dimensional. Right? So if I run this, I'm going to get 1. So what this one means is that this array that we've created here is a one-dimensional array. All right. So we now have the last one, which is data type. So data type will tell you the data type of the array. You can see now that this basically means that your your NumPy array can only have values of one data type. Do you understand? So you can only have values of one data type. If you put a string here, it's now going to convert the array's values to a different kind of data type so as to allow everything to work together. So if I run this, you see that the data type is one weird stuff you probably don't know, and I probably don't know. So you see that is this thing that we have here. So it basically casts everything into a single data type so that it can be efficient and everything can work as an array, right? So that is what makes array unique. Everything here should be of the same data type. If this was a list now, everything does not necessarily have to be one data type. You can have a string, you can have a float, you can have an integer, you can have even a list inside a list. You can have a list inside a list inside a list, right? So the complexity of lists makes it inefficient to work with when it comes to numerical computation. So this strictness that NumPy places is very necessary, right? So that is what we mean by having just one data type. So let me just change this back. So now we're going to have this. So D type here is what int 32. So NumPy looked at all the and see that they are actually all integers. So it's going to make the data type integer. So if I put a float here, 4.8, you see that the data type will automatically be a float now. So because there is one particular float element or value in this list or in this array, NumPy is now going to convert every other value here to a float. So everything is going to have one consistent data type. I hope that is very clear. I hope this is clear. I don't want to dwell much on that. So you can specify the data type even before while creating your array. So if I want to specify my data type, I can come here and say type is equals to int. All right, so it's going to be int, right? So you give us this int 32. If I want it to be float, I can say d type is equals to float. All right, so this is how we can manipulate or change our data types in arrays or array data types. So those are the different attributes we have in our array. We've looked at shape, size, n dimension, and d type. So I hope that's very clear. We're going to be using that as we move forward. So let's now look at how we can create two-dimensional arrays. So creating two-dimensional arrays. So to create a two-dimensional array, let's say array 2D. I have to come here and say np.array, right? So now to make it understandable, you just once your cursor is in between the opening and closing bracket, just press enter. So it kind of expands it for you, so you can like create your array and it will be presented presented very well. So I'll come here and then have now for two-dimensional array, it will have two brackets, opening and closing. All right, it will have two brackets, opening and closing. So once you come in between the brackets, just you will now start writing out the values. Let's say you want to have 1, 2, 3 for the first one. So this is your first row. So your second row would now be followed by a comma, and then let's take it to the next place and then say 3, 4, 5, 6, then comma, and then we're going to have 7, 8, 9. Then the last bracket here, and then followed by another bracket. So this is how we can create a two-dimensional array. So this is basically a list inside a list, right? So in Python, if we take this is a list outside list, and then we have elements inside that list which are lists. So this is how we can create. So if I run this is going to become an array, and I come here and I say array 2D. You see that it has converted it to array. So if I now start to check the shape of my array, let's say I'm check array 2D dot shape, what am I going to get for this particular array? All right, Felix said 3 3, Jennifer 3 3, digital focus. Please, those that have like names that those not correspond to their actual name for this program, please change it. Like digital focus. Now I'm very sure this is not your origin, this is not your real name. So please change it to your first name and last name so we can work with it like and know what we are doing. All right, so yeah, we are all correct. So we have 3 by 3. Right. So the first three is what? Okay, let me change this. Let me make it even better. So I'm going to have 10, 11, 12. So I have 4 by 3 here. So now which one of this value here corresponds to the row and which one corresponds to the column? I like this. We are actually following. So yeah, the first value corresponds to the row, while the second value corresponds to the column. So that's basically it. So you can manipulate it as you want. If I want to add more, let's say 4 2. Okay, let me just do this first. If I do this, I'm going to get an error. Now, this is very important to know that each of the inner lists of your each of the inner lists must correspond in terms of size. All right. So you will see the value here, setting an array element with the sequence. The recorded array has inhomogeneous sample after one dimension, blah blah blah. So what is basically trying to say is that let all your all the lists correspond in terms of size. So if I make this to be 5 elements, all your rows rather, let all your rows, let's just use the right word, let all your rows correspond in terms of size. You have to make it the same thing. Yeah. Come back here, make it the same thing. Come back here, make it the same thing. So if I run this, what is going to be my shape for this array now? What's going to be my shape for this array? Okay, so people are saying 4 by 5, some people are saying 5 by 4, some people are saying even saying 2 by 5, right? Some people are saying 20, some people are saying 3 by 5, some people are saying 5. Right? So obviously some are correct, some are wrong. So the correct answer for this is 4 by 5. 4 by 5. Why? We have 4 rows, 1 row, 2 row, second row, third row, and fourth row, which is 4, right? So the 4 should come first. And then for column, we have first column, we have second column, we have third column, we have fourth column, and we have the fifth column, which is 5. So 4 by 5, not 5 by 4. 5 by 4 is a whole different thing. 5 by 4 basically means 5 rows and 4 columns. 4 by 5 means 4 rows and 5 columns. All right. I hope that is very clear. I know it can be easy to mix up this whole rows and column stuff, but please try to understand it that row come first before columns. Rows come first in NumPy before column. Rows come first before column. All right. So yeah, exactly. The fourth is row, then column. So this is how we can create two-dimensional array. So if I check this now, so what is going to be the size? If I do size, what is going to be the size of this array? What's going to be the size of this array? Exactly. It's going to be 20, all right? So basically, to know the size, just multiply the row and column. So the row is 4, the column is 5. 4 times 5 is what? 20. You've gotten the size of the array. So that is the size. If the size is 2 by 4, if the shape is 2 by 4, the size will be what? 8. If the shape is 10 by 5, the size will be what? 50. So you just multiply your row and column and to get your size. So if I run this, I'm going to get 20, all right? So for n dimension, this is 2 dimension, right? 2, we got 2 here. And for data type, this is going to be what? So what's going to be data type for this particular array? It is going to be what? An integer, all right? Integer. So I believe you are all understanding how to work with, how to create arrays at this point. So the last array that we're going to be looking at is the third dimensional, three-dimensional array. Hope we are still following, and hope everyone is following and can see my screen and hear me clearly. I do this like at intervals just so to ensure that everything is still well aligned. All right. So now we're going to look at three-dimensional array, and I want you to follow me carefully, because this three-dimensional array can be confusing for those that are like trying to still understand everything, right? But if you followed up to now, I believe it shouldn't be a problem, all right? So for three-dimensional array, we have, so that person asking, what is the 32 in 32 mean, sir? Just leave that. That is out of the scope, right? So if we look at that, it's going to take us to a different thing entirely. That has to do with the way things are in numbers or data is encoded, right? So we have 64 and we have 32. Well, just leave that. So I like your curiosity. When it comes to this, you can actually look it up after the class. But for the sake of this class, the things that I don't pay emphasis on basically mean for now you should just keep it aside. But at your spare time, you can look it up and just explore and know exactly what it does. All right. So for three-dimensional array, we have 3 dimensions basically. So let's see how we create it. Array 3D. So the way we create our 3 dimension, we can come and say np.array. So what do? You put your cursor in the middle here, and then you press enter. So this is just to give you space to do what you want to do. So 3-dimensional array, we have 3 brackets opening and 3 brackets closing. So it's in the middle of this thing that you now have your different values. So I want you to pay attention to how it is arranged. You can see that in 2-dimensional arrays, we have at the beginning 2 brackets opening and 2 brackets closing, right? So in 3-dimensional array, it's going to be 3 opening and 3 closing. Now, 3-dimensional array is basically an accumulation, not accumulation, it's like bringing in different 2-dimensional arrays together into one array. That is what 3-dimensional arrays are. It's like bringing multiple 2-dimensional array into one array. So how do we do this? So you know how to write 2-dimensional array, right? So you can just come here and ignore this first bracket. Ignore this opening bracket and this closing bracket for now. Just work as if you are creating a 2-dimensional array. So you have your 2 opening and 2 closing, right? So first of all, you're going to come here and create your 2-dimensional array. Let's say we want to create 1, 3, 4. All right. Then we come comma and come to the next place, and we say 3, 1, 3, 2, 3, and then let's just create one more. All right, and we have 4, 6, 5. So this is a two-dimensional array, right? But then we have to create a three-dimensional array. We have to add another two-dimensional array, right? So to do that, you just put comma and then go down and then create another two-dimensional array, right? And come to the middle and say 2, 3, 5, then comma, come here and say 3, so just random numbers, right? And then comma, and then come here and just this. So this is how this is three-dimensional arrays basically, right? So you have one two-dimensional array, then followed by comma, you have another two-dimensional array. You can actually go on and have more two-dimensional arrays. So what three-dimensional array basically mean is that you have a stack of two-dimensional arrays, right? That's basically it. So this is how you can just arrange it to make it very clear. That's why I told you to separate this opening and closing bracket so you can write everything here. So just if you follow this method, this for your initial practice, it's going to help you understand it, right? But once you understand it, you can just create it as you like without doing all this arrangement because you still understand it. So if I come here and I say array 3D, you're going to see I'm going to have this output. If I come and say shape, what do you think I'm going to have? I know I've not done it, but what do you think I'm going to have? What do you think is going to be the shape? All right, Felix. Felix, seems like we're going to give you most active person during the live class because you are actually very active, and that is very nice, which I want from almost everybody, like everybody actually. So Felix said 2 by 3 by 3. Alabi 6 by 3, Godwin 2 by 3 by 3, Manfred 30, IFA 6 by 3. So I think those person saying 30, you still don't understand what shape mean and what size. Let me just explain. Size is the total number of everything in that particular array. Just count everything. That is the size. But for shape has to do with the dimensions, your rows and your columns. All right. So for this particular dimension, that is the third dimension, the shape is going to be 2. So the 2 corresponds to the number of two-dimensional arrays you have. So in this case, I have 2 blocks. Let's just call it blocks. I have 1 block and I have another block. So we have 2 blocks. So now come to each of these blocks. In each of these blocks, what is the dimension of each block? So the dimension we have in each block is what? 3 by 3. So now the shape of our 3D array is going to be 2 by 3 by 3. So if I come here and I run this shape, you're going to see that the shape is going to be what? 2 by 3 by 3. So the first 2 here does not correspond. In 3 dimensions, the first 2 is not the row. Take note of that. Unlike normal other dimensions where the first value is usually the row, in 3 dimensions, the first number is not the row. The first number is the number of blocks or the number of two-dimensional arrays we have. Then the following number is now the row, and then the last number is now the column in each of those blocks. I hope that is clear. So let me quickly modify this to see if you understand what I'm saying. Let's have additional stuff here. And they must be of the same size, each of them. They must correspond. Any number size you have here must be the same size you have here. All right. Any size you have here, if they don't correspond, you're going to get an error. So this is the error, the same error you got before. So NumPy is very strict with all these things. So you have to make sure that they are homogeneous. So I'll have 5 here. I'll have 2 here. I'll have 4 here. Let me create another block. So I'm going to have another block. I'm going to have 4, 5, 4. So come here and put my comma. I'm going to have 4, 2, 7, 8. I'm going to have here and put my comma. I'm going to have 4. No, let me change it. 5, 2, 1, 7. All right. So what's going to be the shape of this particular 3D? Some people are saying 3 by 3 by 4. Okay. 3 by 3 by 3. 3 by 4 by 4. 3 by 4 by 3. Like this thing basically just requires you to count. Like it's nothing, there's really nothing complex about it. Just count. We have 3 blocks here. That is the first value. In each of the block, what's the shape? In each of the block, we have 3 rows and 4 columns. So it's going to be 3 blocks, then 3 rows for each block and 4 columns. So it's going to be 3 by 3 by 4, right? So that is basically what the shape is going to be, all right? So if we print out this array.shape, it's going to be, let's remove this. It's going to be 3 by 3 by 4. That is going to be the shape of our array. You understand? So that is basically it for our different arrays on how to create arrays and how to work with 1-dimensional, 2-dimensional, and 3-dimensional arrays. So if I come here and I say size, so what's going to be the size of this array? Just multiply these 3 stuff here. All right. So that's going to be the size of this array is going to be 36. 3 times 4 times 3 is 12. 12 times 3 is 36. All right. So just multiply everything or count everything, and you're going to get the size. If I check for n dimension is 3, which corresponds to the 3rd dimension, right? So that is basically it for creating arrays. I hope you understand it. So from tomorrow, we're going to look at how to slice access elements in our arrays, and then look at basic operations in NumPy, element-wise, array broadcasting, vectorization, and all of that. So I really hope we finish this tomorrow because we quite have a lot to do. Anyways, if we don't, we're going to continue next week. The most important is to ensure that we are getting to understand what is being explained, not to rush anything. Like you definitely get to meet up with the curriculum, definitely, but I want us to get the things that are being dished out in these classes. All right. So I am very sure that we've gotten to understand what NumPy is and how NumPy is being used, and the core concept in NumPy, which is an array, and how we can manipulate arrays, create arrays basically, and work just at this level, just create arrays and what arrays are, the different dimensions of arrays. So this is a good starting point for you, because tomorrow we're actually going to be going deep tomorrow. I'm not going to go back to explaining what arrays are. We're going to be looking at how we can access these elements in our arrays, how we can perform operations on arrays, all these mathematical operations. So because of the different dimensions, you now have to understand how these operations are performed on the different levels or the different dimensions. So it's not like what you are used to. It's not like the normal list, or it's not like the normal thing that we've looked at when we looked at arithmetic operations. So you have to understand how arrays are structured, which I took my time to explain today. If you don't get anything, go back to the video, which will be uploaded, and watch it again. The material is also available for you to work with. Practice, very, very important. Try creating arrays yourself. Try doing all these things that we've done today, and it's going to stick, right? It's going to stick, like definitely. So that's going to be it for today's class. I'll be taking questions now. So if you have questions, please let your question be related to what we are doing in class now. I'm begging. Like if it is related to anything aside class, maybe assignment and all that, please let that be handled separately on the group or via the class shop and the assistant. Let every question you're asking now be pertained to the class that we just had. All right. Thank you very much as you comply. So if you have any question, you can just indicate by raising your hand, and I'm going to call you up, and after that, we'll call it a day. All right, Manfred, you can ask your question.
Good evening, sir.
Yeah, good evening.
Sir, please, thank you for the lesson. I got everything up to this point of this 3 by 3 array. Please, sir, I just wanted to go over it one last time. You said that it's a stack of 2 dimension. Then is it that when we say like this first block is 1, the second block is 2, then since it's 2, then the remaining 2 digits, like the remaining 3 by 3, like for the first example you did. So we start counting the rows and the columns, because so that what I'm asking is because of if the blocks are also increased, like how do I just like how it is now on the screen. Like I just
Yeah,
count 1, 2, 3 blocks first. So I write my three. Then
yeah,
before I look at the
yeah,
rows and columns. Is that so, sir?
yeah.
Okay.
Yes, that's just it. Like your first value is the number of blocks you have there. So if I come
Okay.
here now and I add another block, let me just copy this for the sake of time. And I had I have another block here. So what do you think is going to be the shape of this one now, of this
Okay.
array?
1, 2, 3, 4. So this would be 4 by 3 by 4.
Exactly. So you understand
Oh,
it. What are you now?
I
What's now
just
your
want to be
question?
just want to be sure, sir. I'm
Exactly. So
sorry.
that's basically it.
Thank you.
So I
Thank you. I
believe
appreciate it.
that's
Thank you.
straightforward, all right?
Thank you, sir.
So any other question? God will enjoy. Ask your question. You're on
Hello,
mute,
sir.
God will enjoy. Please ask your question.
Yeah, yeah,
Yeah,
good
good
afternoon,
evening.
ma'am.
Good
Oh, good
evening.
evening, sir. Thanks for the class. Okay, so what I want to ask is related to what Manfred asked. So I'm still confused as to how come is 4 by 3 by 4.
Okay, where does your confusion start from so we can know how to handle it?
Sorry, come again, I didn't get that.
Where is your confusion starting from, or where did you understand it to?
I understand it when before you added the third and the fourth block. So if you said the rows come before the column. Hello?
Yeah, yeah, yeah. Okay,
Please.
I think I understand what you're trying to do. You are using the idea of 2 dimension to interpret this 3 dimension. That's why I told you that for 3 dimension, we have 3 values representing the dimensions of the array. For 2 dimension, we will just have rows and column, right? Do you understand that for 2 dimension?
Yes, yes.
Exactly. You have rows and column, you count it. For 3 dimension now, we now have an extra layer where we now
Mm,
have a stack of 2 dimensional arrays. So for you to get the shape of that array, you have to count the number of 2 dimensional arrays we have that are stacked, or blocks
mm,
that we have. So in this case, we have 4 of them. So this is not a row. These things are not rows. This block, I
okay.
mean, this block now that we have
Mm,
here, block is not a row. So you don't count row one, row two, row three, row four. No. What you count is
oh,
block one, block two, block three, block four. You now write out that four, which is like
okay.
the block. It doesn't have a specific name, but depending on what you're doing, you might have a different name. All right. So for each block now, how many what is now the dimension for each block? So that means each block, all blocks need to have the same dimension. You understand? Because if there's
Mm,
a mismatch in the number of dimension, it will not work. It will give you an error. So the dimension you have in this block is the same dimension you have in this block, is the same dimension you have in this block. So you have to check one of the block to know the dimension. So this dimension is 3 by 4. So automatically all other blocks will have the same dimension. So that means the shape of this your array will now be 4, which corresponds to the number of blocks. Each block is a
yes.
two-dimensional array, right? So 4 by 3 by 4. So the 3 by 4 now is the rows and column for each of the block. Is this still confusing,
Okay.
or like are you
No, no, no.
are you still
I
like
understand.
confused about anything? Anyways, you can
I
still go
understand.
over it. Yeah, anyway, that is fine. But if you still need clearer explanation, the video will be made available, so you take your time to to understand it, right?
All
Okay,
right. Thank you,
so
sir.
the last person here, Chinonso Ogunaya, please ask a question, then we'll call it a day. Hello, Chinonso, you raised your hand, so please ask your question.
Hello, good evening, sir.
Yeah, good evening.
Please, my question goes like this. Can we access this array with indexing? Like,
Yeah, we can. That's what I'm saying. If you check the material, right, the indexing is the next thing that we're supposed to do. You can see it here.
okay,
Assessing elements and slicing arrays. So that is what we're going to continue from tomorrow. But I need us to understand the arrays first before we move on to this, so you will not get super confused, right? So by tomorrow, we are going to look at how we can access elements and slice arrays. All right? Is that clear?
okay. Yes, sir.
Okay.
Thank you.
That's fine. So I think that's going to be it for today's class. Okay, we have some more people. Okay. And Cliff, your hand is up. Please ask your question. And Cliff, you raise your hand. Please ask your question.
Hello, good evening. Can you hear me?
Yeah, I can hear you.
Okay. Please, I just want to ask. I don't know. I don't want it to seem as if I'm asking the dumb question, but what exactly is the application of this whole array, the NumPy? How exactly is it that when we want to do some calculations, we come to Python to use Python instead of using regular calculative method? What exactly is the application of this?
And Cliff, I
Hello, can you hear
think,
me?
yeah, I can hear you. It's important
Hello.
that, yeah, I can hear you. I understand where you're coming from, and you are you it's curiosity that is driving you at this point, but it's important that we walk first before we run and then before we fly. So this is just like the starting point, right? The reason why we are explaining or like teaching arrays is because in the subsequent classes we are going to be using them. Is going to be part of what we are going to be using, and even if we don't use it directly, it's going to be what is working behind the scene to give us what we are seeing. So in machine learning, this is going to be very important. All right. So what I just need from you is just to follow us. Everything we are doing is like a build up. It's like a build up. There is nothing that is irrelevant, and your questions will be answered like in subsequent classes. Like, oh, so this is why he was teaching us this array 2 dimension. Oh, it makes sense now and all of that. But just follow us as we are moving. All right. So I'll definitely make use of this. Right. Eh, um, but just to answer your question, these arrays they are very important when it comes to matrix multiplication. So matrix multiplication is what drives machine learning. So in machine learning, we are going to be doing a lot of array manipulation and numerical computing. So it's important that you understand the basics and the foundation before we move to that. Before we now start doing all of that. You understand? So even in pandas, arrays are actually also the backbone of pandas when you are doing data frame manipulation and you are using it to you are basically performing analysis and all of that. So yeah, you get to see the use case of all of this as we move forward. Just stick with us and just make sure you attend classes. All right. So Abdulhamid Adebanjo, please ask your question. Will you be the last person that will take question from? All right. So
Don't bother. I've gotten everything I want to ask. Thank you.
all right. Fine. Okay, so we're going to call it a day at this point. Thank you all for sticking, and we would be yeah. So any other question? We've actually overshoot our time. Any other question should come in the Q&A chat, and I'm going to reply as soon as I can. So thank you very much. Please, as you normally do, you are definitely learned a lot. You can't tell me you didn't learn anything in today's class. So just let me know in the group chat. Just let me know in the live class. So very important to do, as very important for you and very important for general class as well. So thank you very much. You have a splendid night, and enjoy the rest of your weekend. See you tomorrow by 5 p.m. And the recording should hopefully be made available before tomorrow's class. And also, I'm going to give you an update on the week 2 assignments. Hopefully, it is completed before tomorrow's class or not, or just it will be completed this weekend. All right, so cheers and good night.